Plato's divided line is an analogy, and it is a geometric analogy. It uses geometry in order to explain Plato's or Socrates' metaphysics. But I do call it the mundane geometry because the geometry is not high-end. This is simple geometry. And I try to make it as simple as possible. But I'm going to do the geometry here on the board so that you see the construction is doable by hand and it's not too complicated. And I'll sort of walk you through it, you know, as we go along. So I'm going to call this point. So I've drawn a circle, and then I put the diameter through the circle. And this intersection with the circle, I'm going to call A, and I'm going to call this B, okay? And then this is going to be the line. So the line is AB. And as the name divided line suggests, we're going to divide it in a particular way. All right. Okay, so this is the geometric construction that we're given. We're going to take a line, and we're going to divide it into two unequal sections, and then cut each section again into the same ratio. So we have a line here. Here's the midpoint of the line, and I'm going to arbitrarily divide it. Arbitrarily, right? No specific ratio. And we'll call this point C. All right, so there's a ratio between AC and CB. And let me check my notes to see what I want to write down here. CB to AC. So the arbitrary ratio that we've cut the line into is this length AC to CB. All right. And then so we did this first part. We took a line, we divided it into two unequal sections, and then we're going to cut each section here by the same ratio. How do we do that? We're going to use simple geometry to do it. So first off, what I'm going to do is I'm going to make a perpendicular. So this is like a compass, right? You can use a compass, and then I'm going to use a straight edge. So this is all by compass and straight edge. And so I'm going to take a perpendicular here. And we're going to, so by construction, this is a perpendicular right here. This is a right angle. And then I'm going to call this ABC. Point D, and I'm going to connect these. All right, and by Thales' theorem, this is a right angle. So that is a right angle by Thales' theorem. That's why I did the circle. So if you inscribe a triangle with one of the sides being the diameter and the point here, the peak of the triangle being on the circle, then this angle is a right angle. That's just a theorem. And so now we have a right triangle. And we're just going to use, basic ideas about triangles and similar triangles in order to complete the construction here. So what I'm going to do is I'm going to, let's see, how am I going to do this? Right. So what I'm doing is I'm constructing now this line that is perpendicular to AD. And now, hopefully, just sort of intuitively, my lines are a little off, but intuitively, hopefully you can see that this blue, I'm going to make it blue here. This blue triangle, this smaller triangle, is similar to this larger red triangle. And just sort of from an intuitive perspective, they're the same shape. One's bigger, and one's just a scaled down version of the bigger one. And it's that scaling that's then going to give us the proper division of the line. So I'm going to now drop in a perpendicular here. And so by construction, this is perpendicular here. And now this perpendicular matches up with that perpendicular. Right? They're in the same place in these similar triangles. So now AC, and let's see, we're going to call this E. And we're going to call this, I'm actually going to call this G, because I'm going to I have things in my notes. So now this lower section has been divided by the same ratio. This is to this as this is to all of this. They're in the same ratio. So that arbitrary ratio now, we get AG is to GC. That's the same ratio. And likewise, we can do the same thing up here. Let's see. Let's use a different color. And so I'm constructing again another perpendicular. So now we have right angle here. This green triangle is similar to the red triangle, is similar to the blue triangle. They're the same shape. The red's biggest, then we scale it down here, and then we have a smaller scaled down version with the green triangle. And again, I'll drop a perpendicular from the altitude here. And so now we're going to have, I'm going to call this F, and I'm going to call this H. So now we have the line divided according to the construction that Socrates gives for the analogy. So that now CH is to HB is on the same arbitrary ratio. So I'll put it in here. To HB. Okay, let me check to make sure that I did everything. All right, and of course, what we're relying on here is a similar triangle. So triangle ADB is similar to triangle AEC, is similar to triangle CFB. So triangle ADB is similar to triangle AEC, is similar to triangle CFB by construction. I constructed them that way. And because of the properties of similar triangles, we know that we have the same arbitrary ratio here, just as we were instructed to do. So we have a line. We cut it into two unequal sections, and we cut each of those sections again into the same ratio. And this is all the geometry there is in the divided line analogy. So there's no more geometry given, and we've done it. So here we have the line divided, and we have these 1, 2, 3, 4 segments. Does everybody see that? Are you with me? This isn't too bad, right? Just don't worry too much about all the details, but intuitively, hopefully you see that these ratios match up. Right? This is to this, as this is to this, as this is to this. Right? They're all proportionately in the same relationship to one another. They're proportional. Okay. And that proportionality, of course, is very important here. And we notice, again, we're talking about mundane geometry. There is no sacred geometry required. Okay, because often when you get discussions of Plato's divided line, that gets into mysticism about the geometry. And so I'm suggesting that there's no mysticism here in the geometry. Right? It's just a simple, mundane geometric construction. Because when we get into this sacred geometry stuff, maybe we miss the point. If we're going off on a tangent about sacred geometry, maybe we're not getting the plain meaning. And so I think the best place to start is with the plain meaning, the literal meaning, the basic meaning, and then if there's something more mystical involved, it should all correspond to the basic literal meaning. So I'm going to show you what I think is the literal meaning of the divided line. Now, in the Republic, we get the analogy of the sun comes right before the divided line analogy, and then in the middle of the divided line analogy is embedded the discussion of Plato's cave. Are we all familiar with Plato's cave? Yes. Right? We know what that is. Well, that's in the middle of the discussion of the divided line. In fact, Plato's cave on this interpretation is intended to explain the divided line, and especially the main point of the divided line. So if you're not thinking about the divided line while you're thinking about Plato's cave, you're missing something, all right? And we often do discuss it out of context. So this is the context for Plato's cave. And then another part of the context is the analogy of the sun, which comes right before the divided line. And the analogy of the sun, here's a short sort of synopsis of what it is. Socrates is saying, is it not true that the sun is not vision, yet as being the cause thereof, being the cause of vision, is beheld by vision itself? That is so, Glaucon said. This then you must understand that I meant by the offspring of the good, which the good begot, to stand in a proportion with itself, as the good is in the intelligible region to reason, and the objects of reason, so is this in the visible world to vision, and the objects of vision. All right, so what are we saying? Well, one thing I really want to point out here is this word proportion. So in Greek, it's analogia, which is where we get our word analogy from. And remember that the divided line is an analogy. But there's this trading off of meaning between a geometric proportion and an analogy, as we normally use the word analogy. And so those meanings trade off of one another in ancient Greek, and that's what Socrates is leveraging here. So this proportion holds the analogy of the divided line. Okay. And what we're going to see here very shortly is that Socrates is thinking of the good up here and the sun being right here. And so the analogy of the sun really plays into the analogy of the divided line. They're intimately connected. And I'm going to show you how that happens. And so, let me put this here. That this is the analogy. The proportion is the analogy. And notice the way that he phrases the analogy of the sun: as the good is in the intelligible region, so is the sun in the visible region. Just the way that we talk about analogies. And we'll see this sort of phrasing occur throughout the rest here. All right, so continuing the analogy of the sun, Socrates says, conceive then, as we were saying, that there are these two entities, and that one of them is sovereign over the intelligible order, and the other over the world of the eyeball, not to say the sky ball. You surely apprehend the two types, the visible and the intelligible. So, which region is the visible? We're going to have this here as the visible, right? That's the visible region. And here we're going to have the intelligible. So we have the good shining on the intelligible region, things of the mind, and we have the sun shining on the visible region. And so the analogy of the sun is that the intelligible region itself is not the good, but the good is what makes intelligible things happen. Just like the sun is what makes the visible happen. Right? Without the sun, no vision. Without the good, no intelligible things. Right? And then notice the Greek words here are important, as we will see later on, and I'll bring that point home later. But just pay attention throughout to these Greek. Here, this is in Greek characters, and then this is just sort of a transliteration into English, like how you would pronounce it. But we want to see these connections among these terms. It's very important. Okay. And so in the visible realm, we want then, as an expression of the ratio of the comparative clearness and obscurity, you will have as one of the sections of the visible world images. All right, so we're going to take this area, this region, and we're going to split it, of course, on the ratio of the divided line. And one of these sections is going to be images. And it's going to be that lower section there. By images, notice the word here is iconas, like icons, right? So that's where we get our word icon from, is from this Greek word, icon. And by images, I mean first shadows and then reflections in water and on surfaces of dense, smooth, and bright texture and everything of that kind. If you apprehend, Gaka says, I do. Do we apprehend? So think about a reflection on the surface of a lake. Right? You see the trees, you see the mountains on the surface of the lake. The trees and the mountain are not in the lake. Right? You're seeing just an image on the surface of the lake of the trees themselves. And of course, then the trees and the mountains are here. The images on the surface of the lake are here. Right? So that's the sort of thing that he's talking about. And as the second section, we're going to assume that of which this is a likeness or image. So here we're going to have the material objects. So we have the trees and the mountains, and then we have their images reflected on the surface of the lake. And something now to start noticing is that the images are furthest away from the good. Material objects are closer to the good. But then we're going to have all this region that is yet again closer to the good. And of course, this plays upon the analogy of the sun because the images require the action of the sun, but the sun doesn't just reflect directly on the images, right? The sun shines on the mountains and the trees, and then by that action, we get the images which are then caused by both the sun and the mountains and the trees themselves. All right, so there's this whole idea of this chain of reflection. And then, but then what Socrates is suggesting is that, well, the trees and the mountains are kind of reflections too of something of a higher order. Okay. And so we get that, and notice the division in respect of reality and truth is expressed by the proportion, by the analogy, as the opinable is to the knowable, so is the likeness to that of which it is a likeness. So he calls this the opinable, what is of opinion. This is knowable, images, and the things of which they are images. And it's on this proportion of the divided line. They're all in the same proportionality, so that we get this. And so, and when we read this in geometry, we say that AC is to CB as AG is to GC as CH is to HB. The same sort of as blah, blah, blah is to such and such, so such and such is to yada, yada, yada. Right? That's the way we speak of proportions, and that's the way we speak of analogies, even in English now. 2,400 years later. Yes, go ahead.
Did Plato mention what is the good?
Did Plato mention what the good is? Well, that's the question that Glaucon keeps asking him, and the other disciples. They're like, yeah, but Socrates, could you tell us what the good is? And he's like, well, I don't know that I really can explain it correctly, but let me tell you this. And then he goes into the analogy of the sun and the analogy of the divided line. So this is his explanation of what the good is. The best he can do, and he's a little leery about really trying to say it too directly. He's like, this is as best I can do to kind of explain what I'm talking about. and of course the allegory of the cave then explains why it's so difficult for Socrates to explain. Right? Well, we'll talk about that in a little bit. And so now we want to focus on the intelligible realm. So we did the visible realm. We have this breakdown. And then again, there's going to be a breakdown here. So we're going to have a segment here and a segment here. And so we need to get the terminology straight as to what we're going to call that. He says, then consider again the way in which we are to make the division of the intelligible section by the distinction that there is one section of it which in which the soul is compelled to investigate by treating as images the things imitated in the former division. So the things imitated in this division are the material objects. And there's this section of the intelligible realm when the mind is using this sort of way of thinking, it thinks of material objects as reflections of this. So we come up with like a theory, like let's say a geological theory about how the mountains were formed. And then we're saying, well, the mountains actually reflect this geological theory, right? And so in this region, we use assumptions. We use hypotheses. Just like in the study of geology, you come up with a theory, and then you try to see how well the physical world conforms to that theory. And so when we think in this way, we don't proceed up. We don't proceed up. We start with a hypothesis, and then we proceed downward into the physical world. And so that's the way that we think when we do hypothetical thinking, what we normally would call science. But there is another section in which it advances from its assumption to a beginning or principle that transcends assumption, and which it makes no use of images or the sort of analogy of an image employed in the other section. And it progresses from idea to idea. So he's saying that there are non-hypothetical ideas. And Plato tends to use the word idea in a technical sense. These are like the highest things that can be known, or ideas. And then in this region, there are hypothetical essences. And often, if you've looked at Plato's dialogues, Plato's always asking his interlocutor, the person he's discussing things with, for a definition of this or a definition of that, for them to concoct some definition. And these definitions are essences, right? And that's sort of what we do when we're in this hypothetical frame of thinking, is that we have experience, and then we want to distill our experience into some sort of definition, and that then serves as a hypothesis, and then we check, well, does that definition, that hypothesis, does it match the real world? And sometimes it works pretty good, but often we find problems. But he's saying that there's another realm in which you don't need to use hypotheses, that you can perceive with your mind the genuine ideas themselves, and it's non-hypothetical. It's not theoretical. You actually perceive the ideas themselves. Bob, you had a question?
Terminology on the hypothetical, another term could be axioms, like
Yes.
the axioms of geometry and so forth.
Yes.
They're the hypotheticals from which you develop the geometrical system, but you have to realize what the perfections, we call it, if you like, the intelligibles would be the Plato's quote-unquote forms and so forth.
Right.
For instance, perfect triangle or something like that.
Right. So as Bob was saying, we might think of hypothesis here as another word for axiom. Or like in geometry, you have Euclid's 5 postulates. You don't question if you want to do geometry, you don't question the postulates. Right? If you question the postulates, then what? Well, then you end up with non-Euclidean geometry. Okay. But you're not doing it the way that Euclid prescribed. And then, these non-hypothetical ideas, the word idea is actually translated as forms, right?
I have a question about the causal link that you're suggesting exists between the lower level of the intelligible and the upper level of the material. That for one, you're talking about it as hypothetical, sort of theories about material objects. But the theories about the material objects don't cause the material objects. Isn't it the ideas that cause the material objects? And the hypothetical essences are a way that we rise to an understanding of the ideas. I'm just not seeing the causal link between these hypothetical things.
No, that's right. So that's right. So the hypothetical theories do not cause material objects. And that's really the point of what Socrates is saying. But when we are in this frame of mind, when we are theorizing, we sort of slip into that thinking, right? We slip into that thinking that our theoretical understanding, we have a grasp of what actually causes the material objects to be the way they are.
Yeah, well, that's right, because we have a grasp of the ideas through those hypotheticals.
Right. But really the point of the divided line is that is a mistake.
But what is interesting?
The idea that the theories cause the material world.
I thought you had said that at some point.
Well, because that is what he's saying, is that when the soul is using what is going to be called Noya, understanding, it's compelled. There's something psychological that when we're in this frame of mind, it compels us to think of theories as causing the world. But the point of the divided line is that no, there's this higher order of things, which is the genuine ideas that then cause the material world. But if we follow the analogy out, the proportionality, really it's not just these that cause this. Or maybe, yeah, that works. So that is to this as all of this is to all of this. Right? That our theories kind of...
So those are like your icons and images on the bottom. They don't really cause anything.
Right, and they're not really genuine. There's a falsity here. There's a falsity here.
Right, yeah, they're partial representations.
Partial, yes. Imperfect representations. Yes?
So in order for ideas to be formed from the good, from non-hypothetical, they have to be in that proportion, that ratio that we're talking about, in that, or else it is a theory, intangible theory, creating my material objects.
Right, well, the ratio is arbitrary. That's just to sort of get us to the analogy and saying that the point here is that hypothetical essences, theoretical ideas, are like images. Just as material objects are more real than images, non-hypothetical ideas, the forms, are more real than our hypothetical theories. Yes?
Do sciences like biology, physics, can be considered as non-hypothetical ideas or hypothetical essences?
I will get to that in just a few minutes. So that's where this is all leading. So let's get to that. So faculties of the soul. So here we have objects. And then we're going to have psychological faculties that correspond here. So we're going to have a section here, a section here, and so we're going to fill in this sort of portion of the diagram. We're going to call the first division science. So this is sort of getting to your question, right? And then this we're going to call understanding, which is just a sort of term that Glaucon and Socrates kind of come up with on the spot, because normally we would call this science. And Socrates is like, yeah, but we don't really want to call this science. Science is this. This is real, genuine knowledge. This is understanding, something not quite science. And then we have, I'm going to call this sound belief. This is not like faith or something. This is like real belief based on hard experience. And then we're going to have here image thinking. Also translated like as conjecture, right? Sort of fuzzy thinking, like mythology, like when people use mythological reasoning to try to explain the world, that's sort of like image thinking. But then there's sound belief based on real experience, and we see some correspondence between the Greek terms here. Here we have that icon sort of idea, and of course here, noesis is then, we're going to call this intellection. And so this whole section is going to be called intellection. And even in the Greek, there's an analogy between the words. The terminology, you know, Socrates is sort of leveraging the terminology to try to clarify this breakdown. And here he's going to call this doxa, or opinion, which he does fairly consistently throughout the discussion, is that, you know, you may be like a horse trainer, or, you know, like Caesar, the dog trainer. He has very good beliefs about dogs based on experience, right? But then there's other people who just have funny ideas, like they attribute human characteristics to their dogs, and they don't really have a good idea of the way to train a dog, right? This is all a matter of opinion. Some opinions are better than others. And then we have this realm of intellection, where it's really just about ideas, and we have this realm of understanding where it's theoretical. You postulate hypotheses and then derive conclusions from those axioms or postulates. But then there's this higher realm which Socrates wants to call that science. And it's non-axiomatic. It's non-theoretical. And so now this all is part of the discussion of the curriculum for the curriculum. I'm going to have to cut into this a little bit here. So let's call this the curriculum. And again, we're going to have this breakdown. And then this part kind of doesn't follow the pattern. But, you know, they had been talking earlier in the Republic about how the guardians of the state should be trained. And one thing that they emphasized was gymnastics, because these are the people who are going to protect the city-state as soldiers and generals. And so they need to be skilled in gymnastics, which is really like martial arts, like in the context of the Republic. And of course, that's devoted to things that grow and perish, material objects, the body. And so gymnastics, you know, clearly falls within that section. And then, so gymnastics is not the studies of up here, right? You know, martial arts is not these high intellectual studies. These are clearly different. But then there's also this this music they had suggested was important for the guardians to learn about literature and learn about the myths and learn about the songs of the state to convey the values of the state, and all these things are important. But not this high-minded stuff that we're trying to get a handle on. And I don't know, but I think music and arts and crafts, they're somewhere in here, but it's a little fuzzy as to, you know, how do you get this to fit exactly into this the scheme doesn't quite work out, and they're sort of expressing the difficulty of that. But that's not the point. The point is this curriculum at a higher level. And so what I want to focus on here is this realm of understanding and the curriculum for the guardians that falls within this area is now, this is to get to your question about what we normally think of as science, right? And they go through these sorts of studies: arithmetic, plane geometry, three-dimensional geometry, astronomy, and harmony. And remember, this is in 2,400 years ago, 2,400 years ago. But you may recognize these from medieval curriculum of the universities as what we call the quadrivium. But there's really 5 of them, right, that they discuss in the Republic. Plane geometry is 2-dimensional geometry, then 3-dimensional geometry, and then astronomy, the way that Socrates describes it, is taking 3-dimensional geometric objects and putting them in motion and studying motion, the very concept of motion, which we today would think of as physics, which really didn't come to fruition until the time of Sir Isaac Newton, right? So it took quite a number of millennia to get to the fulfillment of Socrates' kind of ideas here about what we normally call science, but what Socrates wants to call understanding. So we're going to have arithmetic, 2D geometry, 3D geometry, motion, and harmony. And of course, harmony was seen as the biggest and most difficult subject because it dealt with proportions, which was actually somewhat problematic at the time of Socrates. And he says these disciplines are useful, but, right? These are useful, but, and that's that big caveat, that but. They're useful for the investigation of the beautiful, that's the good. But if they're otherwise pursued, not for good, not for goodness sake, but pursued in some other way, then they're useless. And Socrates says, I take it that if the investigation of all these studies goes far enough to bring out their community and kinship with one another and to infer their affinities, then to busy ourselves with them contributes to our desired end, and the labor taken is not lost. But otherwise, it is in vain. If you study these things for themselves, or not as a means to the good, but as a means to something else, then they're pointless. Because the end that we are seeking in our republic as good philosophers is the beautiful, right? And so that leaves this to be described. What is above this these normal intellectual pursuits, which we normally call science, but Socrates doesn't want to call them science, he's going to call them understanding, and reserve science for another sort of method of study. Now, there is a certain hang-up here that we run into. And we're starting, maybe, some of us are getting a little uneasy with this analogy and think, oh, well, that can't be right. These things are really the highest studies, and this whole interpretation is off base. and that's what many interpreters of Plato would say. They get stuck on a certain hang-up here that's built into the analogy, that's built into this proportion. And if you do a little algebra here, you will come to the conclusion here, and of course you're just going to have to trust me on this, that I did the algebra correctly. But if we look at this last line, what's the next line? You have this multiplied by this, and this multiplied by that.
GC equals CH.
Oh, G equals CH. Now, but if you do the geometry, that's exactly the way it comes out. Right? The diameter of this circle is bisected by C. CH is equal to GC. The geometry tells us that. That's all built into Socrates' original construction. But many people who think of themselves as scientists and pursuing the highest studies there are, hey, they don't want to accept this. They're like, even commentators on the Republic suggest that Plato got the geometry wrong because of this, because they just can't accept it. They can't accept the main point of the analogy, and therefore go into all sorts of, mental gymnastics about why this would be there, and of course, then one of the ways in which this takes shape is this obsession with sacred geometry, how there must be some kind of sacred geometry, some mysterious geometry in the divided line, because we can't just accept the mundane geometry, that these are actually equal there and they don't follow the proportion, just as we were saying before.
Yeah, because I haven't heard anyone enunciate that before. Normally, we think of that top realm as like purely formal studies as opposed to kind of the mixed studies that you have in harmony, astronomy, these sort of things for mathematical sciences, but they're not purely formal. And then that upper realm might be thought of as purely formal, things you can't envision, it's just a matter of form, really in Plato's sense, the idols. And, there's, that seems like a prevalent interpretation to me.
Sure. I mean, that's the right interpretation. I mean, that's the plain interpretation that I'm suggesting. But there are commentaries.
You could hang on this hangout?
There's a guy named Farley that has made a big deal out of this.
Majority opinion, of course, then it's one guy.
Well, he did an exhaustive study of commentaries, and
So you're getting from him this critique.
this is what he finds in lots of commentaries. But he agrees with, he says that this is a contradiction in the divided line. And then he finds this interpretation in lots of other commentators, historical commentators.
I just haven't counted that.
Yeah, no. And so this is not a genuine problem. It's only a problem if you think of this as the highest form of reasoning. If you think of this as the highest form of reasoning, then the whole divided line doesn't make sense. But that's exactly the point, is that there's this higher order of reasoning that is the ultimate expression of human rationality in the light of the good. And everything works out nicely. And the analogy works, and the geometry works, everything works. Yes, Ray?
Professor, is that prime or C prime? Is that right? No, on the math. Is that prime or something?
Oh, that's just a typo.
No, next to the edge, is that
Right
prime?
here?
Yeah, it's prime.
That's a typo.
Oh, okay, sorry.
Yeah, I don't know. I don't know what that's there.
Because in
I have it up here too.
yeah, there's different stuff. That's what I mean.
Yeah, I don't know how that got there. Yes.
So, another question too, if you got.
Yeah.
So, the choice of initial ratio that this all starts with.
The choice of the initial ratio.
Yeah. So why doesn't he just say, let's take a line, divide it in half, then divide the other two into halves? You end up with the same regions here. It's just that you're throwing the metric away, But so, is there some significance to the choice of ratio? Does it matter at all whether or not you decide that, let's make our arbitrary cut down here, instead of near the middle or right near the top? Does it make any difference, or is it really just about the order of the different regions on the diagram?
Literally, what's explicit is that it doesn't matter, right? And so I did just do it arbitrarily, right? And so it doesn't matter, and so we get this no matter what, as long as it's uneven.
For half and half, I just wonder why he sort of chooses some somewhat exotic way to do that. Instead of saying, hey, let's take a line, divide it in half, and divide each of those halves again, which would have been simpler.
Well, maybe from our way of thinking, because we think more arithmetically, but in Greek mathematics of the time, it was all geometry based. So they just thought of proportions as geometric.
Okay.
So they wouldn't even write this down, right? This wouldn't make any sense.
Right. So the size of regions that ends up coming out of it doesn't make any difference. You're saying.
It doesn't literally with what's in the text. However, if you do it the other way, which is very common in the commentators, is they make the top section larger.
It kind of bugged me how they did that, but that's why I was wondering what your thought was.
But there is a breakdown. If you do it so that the top section's larger, you do run into some contradictions. Because then what happens, because what Socrates wants to say is that understanding is intermediate between genuine science and opinion. And in this way, it is intermediate in size as well as in sequence. But if you do it so that you cut it below the midpoint as your original ratio, then it's not intermediate in size.
But
I mean, it's still...
I thought that the size of the two middle regions was the same, so they're both intermediate then? Right? Because it should be...
Well, because then this one's going to be bigger than this one. And this is also going to be bigger than this one. It's not in the middle.
GC and CH are going to be the same.
Right, and I think that's where a lot of commentators get hung up on this. So if you have something where it's like this, and then it's like, well, we're going to have to use more space. So it's like this, and then like this, and then like this, and then like this, sort of flip it upside down. Understanding is smaller than science, but it's also smaller than opinion. It's not in between.
Oh yeah, it's smaller than the whole of the opinion.
But here, it's intermediate in size.
Okay, well, yeah, to the whole of the bottom.
So there, you do get some interpretive problems if you don't do it above the midpoint. Okay, Stefan?
So to touch on the significance of the ratio, if this is linked to the allegory of the cave, could you possibly interpret it this way, that the sort of the bottom half of the dividing line, which is the larger part of the ratio, could you say that that's where the majority of our thinking is, and that's where most people, like, per se, live in?
Right, and there's a lot more multiplicity here, right? Even the reflections on the surface of the lake of the trees and the mountains, there's lots of them on the surface of the lake, right? It just multiplies. It just keeps on multiplying.
So I still have no trouble with it because he says it's arbitrary, right? Where it
Yeah.
cuts. It could be way down here. Wouldn't make any difference then. If it's really
Yeah.
arbitrary.
And this would hold regardless.
Yeah, this can always hold regardless, right? No matter where you cut it arbitrarily. So you could make the whole bottom region as arbitrarily small as you want, right?
Yes.
And,
Yeah, it could be as arbitrary as small. But if you start this way, then you do run into a little bit of difficulty. So I'd just suggest that you really follow that out. You know, it's kind of interesting. Yes.
Is Plato in, suggesting that if a person or if understanding such as harmony, motion, or the sciences that we know now is pursued for the good, can we reach the real science?
Yes. And if you don't reach real science, and you're not pursuing the good. But what would many scientists say? I'm not trying to pursue the good. Right? That's not what I'm doing.
Well, it seems characteristic of what's happening at the higher region that we arrive at it through dialectics, right? Whereas in the lower region we could talk about, say, ordinary induction or something like that. But Plato emphasizes dialectic as the method of going from the second region to the top one.
Right, so we're going to get to dialectics here in a moment. But here's where I call it Plato's dungeon. Right? It's not just Plato's cave. It's not just a cave that you visit. It's a dungeon. It's a place it's a prison, and it's a place where people are tortured. He said, compare our nature in respect of education and its lack of such experiences as this. Picture men dwelling in a sort of subterranean cavern with a long entrance open to the light on its entire width. Conceive them as having their legs and necks fettered, right? From childhood. So you're going to take babies and you're going to chain them down so that they remain in the same spot, able to look forward only, and prevented by the fetters from turning their heads, etc., etc. This not being able to turn their heads and being chained and compelled to look in a certain direction is then how this all fits within the analogy of the divided line and this issue about science, right? So this is the big thing. Their heads are prevented from turning. And that's this is the key point about the allegory of the cave or the allegory of the dungeon. And this goes back to this section that we looked at before where I was talking about hypothesis versus non-hypothetical reasoning. And the soul is compelled, just like the people in the cave or in the dungeon are compelled to look a certain way. When the soul is here, it's compelled to look downwards. It looks in this direction. And the soul has trouble turning its head because it's fettered to think in a certain way. You know, if you're in your geometry class and you start asking the professor, well, how do we know that the postulates are true? He's going to say, get out of here, right? That's not part of the study. Yes, Professor
What
Slip.
has to do with the terminology that involves that turning upward. It's kind of the way it's described as a periagoge, which is effectively not raising your head, but rotating your whole body by analogy.
Periagoge.
Yeah.
Yeah.
In other words, what you're saying, that's just a word to describe what that is.
Right.
In other words, you don't look up or anything like this
Not this direction.
in a metaphorical way, your whole self.
You got to turn all the way around.
Yeah. And the other is on the harmony and so forth. Wouldn't that be the problem of not wanting to look beyond that with what we find in contemporary physics and so forth that seem to think they're the top of the line when it comes to science and so forth?
Well, certainly. And of course, for thousands of years, like with Euclid's postulates, no one questioned the postulates for thousands and thousands of years. In fact, many thought that the parallel postulate could be derived from the other four postulates, and mathematicians spent thousands of years trying to prove the fifth postulate from the four other postulates. And then in the 19th century, Lobachevsky says, well, what if we change the fifth postulate? You know, and that's the sort of activity that Plato and Socrates are describing, is that you question the axioms. But we train scientists to be so devoted to their axioms that we see something wrong if they start to question the axioms.
According to Farley, right? Because I don't know scientists like that so much. I mean, really, there's a lot of questioning of postulates and axioms. That's kind of what it's all about. It's a critical enterprise, you know, whether you're talking about axioms or not. Sure, in your elementary geometry class, you're going to just memorize the axioms and go with what follows from those. But someone who's a geometer is
going to question
postulates, and that's how things move forward.
Right. And of course, one of Socrates' disciples was Theaetetus, who was one of these people that he knew personally that questioned the axioms, and then proved he proved that there are only the 5 Platonic solids by questioning the axioms of the day, which then becomes sort of the core of Euclid's book, which was published 100 years later.
Do Platonic solids count as forms, or do they count as hypothetical essences?
That's a good question. But that's sort of even something that in their discussion here at the end, Socrates says, well, let's not get into all that because that's a whole other complicated go-round, right? So I think he wants to leave that vague. But let me just quickly run through here. But you were suggesting that scientists always question the axioms.
I wouldn't say always.
Mm-hmm. Right. So
Not always.
So we have this big distinction between science and understanding. This is just a cleaned up version of what I have on the board here. And of course, here is where we have Plato's dungeon, is in this region. Yeah, so if you look at the allegory of the cave, you can really place the cave in this region. But then the analogy is that this is a dungeon, and that there are people stuck in the realm of understanding, and they can't get out. And they need to get out. Right? Especially the leaders of the city-state need to be trained to ascend above the intelligible dungeon. And for what reason? Well, first of all, it is dialectics, as was suggested. This is dialectic. And just give me one more minute. And then I think the real relevance to scientists is that they don't question things like, why are we doing this? You have examples like...
Again, it seems like kind of a broad claim. You're saying scientists, they don't do this. I mean, some or all, it's...
Sure. Yeah, not all.
Okay.
But some kind of prominent, just reasonably prominent scientists. Some like Robert Oppenheimer, right? Used his intellect, for Hiroshima and Nagasaki, right? And we have Louis Pfizer, who used his intellect for napalm. He figured out how to make napalm stick to the skin of children. That's how he used his intellect. He didn't question the purpose. And I think something here's somebody that we're not as familiar with, but, really is putting us all in quite a stew. James Black was a scientist working for Exxon, and we see here there's a document from 1978 in which he's describing to Exxon executives the dangers of global warming. And he allowed them to use his science to distort the scientific reality. He never spoke up. He never questioned the objectives of the Exxon Corporation. He did not ask the question, is this for the good? Right? So, I mean, this is a certain way of looking at science. It's a little different from the way that we did, especially in the 20th century. But now, today, we are thinking more in this way, especially in light of global warming. That we really need to require our best and brightest to turn their heads, to turn their entire selves around through dialectics and seek the good, right? To conduct science in the light of the good, And I think this is really the point of the divided line, is that all your intellectual studies need to be directed towards the good and the beautiful. And that this is a sort of philosophy of science which is quite different from 20th century understanding of philosophy of science.
Not be value free, no matter what any scientist might say.
Yeah, that science is not value free, and we can't just have technocrats running our republic. That we need to order things in light of the goods for the good of the citizens. That there has to be this values-based approach to science in order to create a well-functioning society, which is what the republic is all about. Is how do you formulate a well-functioning society and how that translates to a well-functioning person, right? So that's the sort of interpretation that I give to the divided line. All right, so we are out of time. If there are any questions that anyone wants to ask me afterwards, I'd be happy to talk to you about that. Thank you for your attention, and I will see you guys around.